Hello, I'm Natasha Gaskin-Peters. I have a PhD in economics and I'm a senior business specialist at the Center for Local Business Development, where I regularly teach the offshore oil and gas course. In our last session, section 4 of this training course in oil and gas, we took a look at the production phase. Now we will look in more detail at the challenges in the offshore environment and some of the main ideas which we introduced during the first section. This will help you to understand the technological requirements and risks that international oil companies and their suppliers must manage while working offshore. There are 4 main areas that pose challenges in the offshore environment: technological, health and safety, environmental, and cost. Businesses in the industry constantly work to overcome challenges in these areas and mitigate related risk. Working at the subsurface requires equipment that can function under the physical conditions of the deep sea. The main challenges of operating at significant ocean depths are intense pressure, extreme changes in temperature, and maintaining reliable remote communication. Equipment and materials require sophisticated engineering to sustain the high pressures experienced in deep waters. At 5,000 feet deep, pressure is roughly equivalent to 2,100 pounds per square inch. Technological solutions include high-performance materials, high-pressure, high-temperature or HPHT pumps and valves. Machinery must also withstand extreme temperatures. Water temperatures at significant depths can drop to 0 degrees Celsius. Thus, additional technology is required to prevent blockages that restrict the flow of oil and gas. Such solutions include electrically heated pipes, chemical products called inhibitors, insulation, and high-performance materials. Conversely, downhole temperatures are very high and can reach over 100 degrees Celsius. The large distance between the surface and the seabed requires special technology to relay information and maintain equipment communications. Umbilical and log while drilling, or LWD, provide communication solutions in this environment. LWD tools work with measurements while drilling, or MWD systems, to transmit partial or complete measurement results to the surface while the tools are still in the borehole. This is called real-time data. Complete measurement results can be downloaded from LWD tools after they are pulled out of the hole, which is called memory data. Because deep water operations can take place at over 100 kilometers from shore, oil and gas cannot be transported to shore quickly and hence must be processed at the offshore site using FPSOs and subsea systems. Deepwater operations are frequently exposed to harsh conditions such as wave motion, winds, etc., presenting challenges to keep large floating structures in position. Positioning solutions include turret and mooring systems, anchoring, and dynamic positioning. Liza Phase 1 is 190 kilometers offshore of Guyana at a water depth of 1,500 to 1,900 meters, over 5,000 feet of water. The vessel has to remain in place for over 20 years, so systems must monitor waves and movement of the vessel. Remember that the first thing we did in this course was to take a safety moment. In the offshore oil and gas industry, a culture of safety is very important since working in the offshore environment is a high-risk activity. To address the risk, Personnel use personal protective equipment or PPE, and companies mandate safety training and safety management systems. Safety planning includes management of rescue resources offshore, medevac and firefighting systems. These are training typical to the offshore industry that guard against the risk of working in the offshore environment. Common training you will find are Tropical Basic Offshore Safety Induction and Emergency Training, or TBOSIET. This includes Helicopter Underwater Escape Training, or HUIT, Sea Survival and First Aid, Safety Induction, Firefighting and Self-Rescue. The industry also upholds standards that are not specific to offshore oil and gas, but commonly seen across shipping operations globally. For example, STCW, which stands for Standards of Training, Certification, and Watchkeeping for Seafarers. Basic safety training is designed for anyone on vessels of over 200 tons going beyond territorial waters. Essentially, if you are employed on a commercial ship, ferry, cruise ship, superyacht, or FPSO, you are required to complete a STCW Basic Safety Training course. All crew should receive basic training to cope with emergencies on board. Basic STCW trainings comprise firefighting and fire prevention, personal and social responsibilities, personal survival techniques, and elementary first aid. Offshore operations present a series of environmental challenges which require additional studies, planning, monitoring, and technology. Oil and gas companies spend significant resources on assessing and mitigating negative impacts to the environment in which they operate. To prevent the possibility of incidents, solutions are put in place such as discharge control, water and mud treatment, and spill prevention. To assess the anticipated environmental effects of a proposed project, operators also undertake environmental impact assessments, known as EIAs, as part of field development planning. While these are called environmental impact assessments, they also assess economic and social risk. Remember that the process for an EIA relies on data and surveys, which can include surveys from populations and stakeholders. Throughout the earlier sections, we discussed some of the significant costs involved throughout the life of an oil and gas project. Here is a review of the major cost areas. Floating production facilities are a major cost component of offshore projects. Costs vary greatly depending on the type of facility and design, but an FPSO can cost over $1 billion. This sample figure and others in this section are for an operation in the Gulf of Mexico and are in US dollars. Subsea systems also add significant costs to deepwater projects. Subsea systems include equipment such as umbilicals, flow lines, risers, manifolds, pipeline end termination or pleats, and pumps. A HPHT resistant subsea pump can cost around $300 million. While logistics represents a small portion of operating expenditures for onshore operations, the intensive use of helicopters and OSVs or offshore supply vessels translate into significant logistics costs for offshore operations. Logistics average about 30% of total offshore operating expenditures. In this session, we've covered the key challenges in the offshore oil and gas industry. These challenges include technological, health and safety, environmental, and cost. We also reviewed some of the efforts taken to prevent risk and manage these challenges, like equipment that meets industry standards and specifications, health and safety training that are common in the industry, environmental impact assessments which take into consideration social and environmental risk, and the magnitude of cost for key aspects of an upstream project. So before we close this section, let's turn to some frequently asked questions from this section, some of which are a good review for what you have learned in the previous sections.
Natasha, this section surely was very informative. In this section, we reviewed the main challenges of the offshore industry being health, safety, security, and environmental, technological, and costs. Throughout this course, people often ask, what are the operators doing to guard against potential environmental risks to Guyana's ecosystems?
Well, Alan, prior to operations, including exploration activities, operators across the industry undertake EIAs or environmental impact assessments, as well as ESIAs or environmental and social impact assessments that need to be approved by the government. They also put in place preventative measures and procedures for emergency situations such as discharge control, water and mud treatment, and spill prevention. Again, these impact assessments take into consideration the environmental impacts as well as impacts on communities. Environmental impact assessments for LISA 1 are available online at the EPA's website.
Interesting, Natasha. We talked about several different trainings, standards, and measures taken in the offshore industry. Can you tell us again, what health and safety trainings are commonplace for companies working offshore?
Of course, Alan. For workers, measures can involve use of specialized personal protective equipment or PPEs and protective gear training. For companies, standards you will typically find include TBOSIET or Tropical Basic Offshore Safety Induction and Emergency Training, which entails HUIT or Helicopter Underwater Escape Training, as well as sea survival and first aid, safety induction, firefighting, and self-rescue. Many often ask if knowing how to swim is a typical requirement to work in the offshore environment. This is typically not required for staff to know how to swim, but it will certainly help to ensure your safety in case of an emergency while working on a vessel or other offshore environment. Importantly, companies each have their own safety measures that they enforce to reduce safety risk in the offshore working environment.
This is good to know, Natasha. At the Center's HSSE courses, we go over some of this content in greater detail, discussing some of the standards and measures that should be in place in the work environment. Many people have been hearing about ISO certification or compliance. The Center is assisting companies with becoming ISO compliant. What is ISO, and do firms really need ISO to work in this industry?
Well, Alan, the International Organization for Standardization has several standards. Put simply, these are a series of international standards on quality management and quality assurance developed to help companies document and verify that they have an efficient quality management system. The Center is currently assisting companies in becoming ISO 9001 compliant. ISO 9001 is a standard that sets out the requirements for a quality management system which helps businesses and organizations to become more efficient and improve customer satisfaction, say for instance in meeting HSSE expectations. In the offshore industry, it is not required to be ISO certified or compliant, but demonstrating the ability to meet ISO standards will help local businesses enter the supply chain. Although not all contractors may require ISO certification or compliance, a firm's ability to demonstrate compliance may help increase their chances of attaining certain contracts.
Certainly very useful information for businesses interested in the standard, Natasha. Now tell me, why is technology so costly for working offshore?
Technology is costly when working in the offshore environment because of the challenges of working at significant ocean depths and distances from shore. Keep in mind that the equipment required to produce oil must be able to withstand the freezing temperatures and drastic changes in temperatures at the wellhead, and it must withstand significant pressures at the subsurface. Equipment with the appropriate technology is extremely costly, but necessary to ensure safety throughout operations. Remember that you can review this section at any time, and if you have additional questions, please post them to the course forum where a CLBD member will respond. You can also visit our website at clbdguyana.com to sign up on the supplier registration portal and find updates on our course offerings. In the next section, which will be our last section in this course, we will look at the situation in Guyana in relation to oil and gas and a project update. I'm Natasha, and I'll see you in my next class as we continue to explore the offshore oil and gas industry.